Suppose that you encounter the following projectile motion problem where an arrow is shot off of a cliff at a 30-degree angle at a speed of 20 meters per second, and the cliff is 10 meters high. You're asked to solve how high it goes before it falls, how much time it takes to reach the ground, and how far it travels. The first thing that you need to know is that neglecting air resistance, any projectile will follow a parabolic motion. The time to reach the max height will be equal to the time it takes to return to the original height. The first thing you should do in any projectile motion problem is resolve the velocity vector into two separate components. The x velocity can be found by multiplying the given velocity by the cosine of 30, and the y velocity can be found by multiplying the given velocity by the sine of 30. In this problem, we find that the x velocity is 17.32 meters per second and the y velocity is 10 meters per second. We can determine how high the arrow will travel by using the following formula. We know that the arrow will be at its max height when the velocity in the y direction reaches 0. Therefore, we can plug in 0 for the final velocity and 10 for the initial velocity. In this equation, the acceleration is actually the acceleration due to gravity, or negative 9.81 meters per second squared. We can rewrite delta x as delta y since we're concerned with the height in the vertical direction. Solving this equation, you will get delta y equals 0.196 meters as the maximum height reached by the arrow. Since we now know the maximum height, we can use the following kinematics formula to determine the time it takes to reach that height. Plugging in the information we know, we get t equals 1.02 seconds. Once it's at the maximum height, we can then treat it as a freefall problem to determine the additional time it takes to reach the ground. Adding the maximum height of the arrow to the height of the cliff, we know that the distance the arrow will need to fall is 10.196 meters. The change in displacement will actually be negative 10.196 meters, since the arrow is traveling in the negative y direction. We can also set the initial velocity to 0, since we know that this is the velocity of the arrow at its highest position. And in this case, the acceleration is again the acceleration due to gravity. Solving for time, you'll get 1.44 seconds. To determine the total amount of time it takes the arrow to reach the ground from the moment it's shot, we can add 1.02 seconds to 1.44 seconds to obtain the value 2.46 seconds. Knowing the total travel time, we're then able to determine how far the arrow travels. This can be done using the following kinematics formula. However, since you can neglect air resistance, acceleration in the x direction is 0. We can then determine the total horizontal displacement by multiplying the initial velocity in the horizontal direction by the total travel time. This gives us a final answer of 42.6 meters, and we have now solved for everything that the problem asks for. You should be able to use this method to solve a wide variety of projectile motion problems. Just remember to always resolve the initial velocity vector into its two components. Hopefully you found this helpful, and as always, comment below if anything's unclear. Thanks for watching.